Good morning. I hope you are doing well. Today I'm starting on Geography Paper 1, 2021. Geography Paper 1, 2021. Remember, my approach is I'm using past exam papers for revision and preparation for the final exam. Let's go through the paper without wasting much time. So I'm going to do question 1.1 and 1.2 only. I'm going to do question 1.1 and 1.2 only as of now. Then I'll do 1.3 separately, 1.4 and 1.5. Okay, let's move on with the question. Various options are provided as possible answers. Various options are provided as possible answers to the following questions. Choose the answer and write only the letter A to D next to the question numbers 1.1.1 to 1.1.8 in the answer book, e.g. 1.1.19. Okay. The first question is about mid-latitude. The mid-latitude cyclone occurs between. So here from the options that are given, this is where you have your tropical cyclone. So which means 5 to 25 is wrong. This is where you've got your mid-latitude. Remember, they are driven by the westerlies. You find them between 30 to 60 degrees north and south. So this is the correct answer. This is 0 to 5. This is where we do not have the Coriolis effect. 60 to 90. This is where we actually this is where we have got the polar easterlies. So the correct answer there is 30 to 90. This is where we have got the mid-latitude in the middle of the latitude. What I'm simply saying is when you look at it like this, you have got your 0 degrees, you have got your 30 degrees north, you have got your 60 degrees north, you have got your 90 degrees north, got your 30 south, 60 south, you've got your 90 south. So what we are talking about is this region, which is the middle of the latitude. This region, which is your 30 to 60 north and south of the equator. So the correct answer there is B. Okay. Mid-latitude cyclone is steered by, which means what drives the mid-latitude cyclone. So here, remember, we have got the easterlies, we have got low pressure easterlies, we have got the tropical easterlies. Here we have got the westerlies. We have got the westerlies. So this is what drives. This is what drives the mid-latitude. So the answer is D. So please, if you have time, please, I've got a live from 6 to 8 o'clock. I'll be explaining this foundation of the concept of mid-latitude, tropical cyclones, subtropical anticyclones, but I'll use the global air circulation. Please make sure you don't miss the live at 6 today. Okay. The change in wind direction in the mid-latitude cyclone, okay, in the southern hemisphere, that is your backing. That is your backing. That is the correct answer there. The front below is that is your warm front. That is your warm front. Remember, if it is a cold front is like this with a triangle. This is a warm front. Okay. Let's move on to the next one. This mid-latitude below is in the, remember when you're looking at the stages of mid-latitude cyclone, where we have got a defined cold front and warm front, that becomes our mature, means it at the mature stage, because we have got a defined cold front and defined also warm front, or let me say a well-developed, I think that's the right word, a well-developed cold front and a well-developed warm front. So that is a mature stage. Okay. 1.1.6, the conditions experienced behind a cold front. Okay. Behind a cold front, there's cold air. Behind the cold front, there is cold air, which means there's decrease in temperature and increase in pressure. Behind the cold front, there's cold air. Ahead of the cold front, there's warm air. Behind the warm front, there's warm air. Ahead of the warm front, there is cold air. Okay, it's actually cool. It's cooler than the cold air that we have here. So obviously, our answer there is A. increase in pressure and decrease in temperature behind the cold front. So behind the cold front, there's cold air. Okay. Then which symbol below illustrate the merging of cold and warm front? What illustrates the merging of cold and warm front is your D. This is a stationary, okay? This is the stationary, okay? This is also a stationary one, there's no movement, but here they have meshed. So your answer there is D. Please make sure you know this, okay? Then the station model generally associated with the cold front in the southern hemisphere. Southern hemisphere, obviously, the cold front, we are saying now a mid-latitude is a low pressure. So it's supposed to be clockwise. If in the southern hemisphere, 1.1.8, we check, of course, it's associated with stable weather conditions, of course. So it means this shows the direction where it's coming from here, going the other way around from here, which means it's going the other way around, which makes what? A clockwise direction. It's going like this. You can see from where it's coming from. So this one is going in an anti-clockwise direction. You can see where this is coming from here and it's heading towards this one. Okay, so the correct answer there is A, which is this. Okay, then let's move on to 1.2. Choose the correct words from those in brackets. Write only the words next to the question number, to 1.2.1 to 1.2.7. Okay, what do we have? So when it comes to this, guys, what comes to your mind is microclimates, okay? To be specific, valley climates. Okay, when you see these arrows pointing downwards, what comes to your mind? Obviously, firstly, the valley is cold, then it cools the air above it. Okay, so cold air, what does it do? It's cold and dense. So what does it do as a result? It sinks. So this is your katabatic, because it's sinking below, okay, down the valley. So when it sinks down the valley, the air that is at the bottom, obviously when it's sinking, is a little bit warmer than the one that is what? That is descending, which is the katabatic wind that is cold. So it means as a result of it being warmer as compared to the descending air, which means it is forced to rise. So as it is forced to rise, it is now trapped with cold air at the top and cold air at the bottom. This is why we end up having this thermal belt. This is how we end up having this thermal belt, which is a parcel of warm air that is trapped between two parcels of cold air that is at the top and at the bottom. Okay, so here, you know, at the bottom at B, when the temperature goes below 0 degrees, that's where we have got frost pockets. So you should always have this in mind so that you don't have a problem. Of course, this one also shows you that this is happening during the night. It shows you that this is happening during the night. Okay, let's go through the question. Air at A cools because of obviously terrestrial, that is during the night. Downward movement of air along the valley slopes, okay, during the, of course, this is during the night. You can see we have indicated here that is during the night. That's where we have got the katabatic wind. That's where also air cools because of terrestrial radiation. Air movement from A to B results in, okay, A to B, of course, that is your katabatic. Anabatics during the day, it will be rising up. Okay, it's associated with warm air, but katabatic associated with cold air because it's during the night. Dew point temperature drops below freezing point. At point here at the bottom of the valley during the night, temperature can drop below 0 degrees, which results in frost pockets. So there is B, is B here. Okay, precipitation that forms at B when the dew point temperature drops below 0, that is your frost. That is your frost that forms when the temperature drops below 0 degrees. Okay, displaced air from the valley results in it results in a thermal belt. It results in a thermal belt, but you can also accept invasion layer. Both are correct, but it results in a thermal belt. That's what I was explaining, that when this cold air is descending, because it is dense, it is heavy and cold, so it sinks or it descends down the valley. Okay, so what happens is what is at the bottom of the valley will be warmer than the one that is descending. Okay, so it is forced to rise. As it rises, of course, it's creating space, so this space is filled by the cold air that is sinking. So what is happening now is the cold air, there will be cold air at the bottom and cold air on top, because this is during the night. Hence the warm air is trapped between the cold air here and cold air at the bottom. So this is your thermal belt. That's basically what we are talking about. So it's a thermal bed. Invasion layer, of course, this when you talk about invasion layer, this is when you've got an increase of temperature with an increase in height. So this is also a form of invasion layer. Okay, so both are correct, but the most correct one is thermal belt. Okay, layer C is more developed during, okay, this one is developed during the night. That's when we have a thermal belt. It's developed during the night. That's why we have got a thermal belt. So boys and girls, that is it in as far as this paper is concerned. 1.1 and 1.2, I've covered that. Thank you so much. Have a blessed day.